Hi everyone, I'm your physics faculty Bharat. Okay, so today we are going to discuss about photodiode application. Right, so application of photodiode. So where we will use this photodiode. In the last class we have discussed about several key points. So the photodiode will work in reverse bias condition, right? So it works in reverse bias condition. Then the incident energy, okay, of the photon should be greater than the band gap of the semiconductor, right? And whenever photon is incident on that depletion region, okay, so in the depletion region we will have a transparent window, right? So the transparent window will be there in depletion region, right? So whenever photon incident on it, electron and hole pair will be created, okay? So electron and hole pair will be created, and because of the electric field, electron will move towards the N side, okay, and hole will move towards the P side, okay. The hole will move in the direction of the electric field and electron will move in the direction opposite to that of the electric field, okay. And whenever the intensity is increases, what will take place? Whenever the intensity increases, the current is also increasing, okay. Some of the students will see about here I is not used to, okay, in your NCERT what they have given here, I1, I2, I3 given. It is not current, okay, it is intensity, okay, I1, I2, I3, right? So don't confuse with the symbol I. It is used to, okay, indicate intensity, right? So now what we are going to see is, so where it works, okay, the application of the photodiode, right? So we are studying about photodiode and where it will be useful. So it is present in every home, okay, even in your home and even in my home, okay, it is present at every home in our country, okay. For example, just consider a TV unit, right? So we are having TV, right? So you can see that bada size LED TV, whatever it may be, right? Okay, you will have a remote, right? So you will have a TV remote, okay. And see here, I am going to have an AC, okay. For this AC also I will have a remote, right? So when you press any button on your remote, okay, so a photon will travel, okay. It has to be received by this TV, right? Then so what kind of reception you will made in your TV? So here only we will have our photodiode, okay. This photodiode is present here, so it is used to receive the signal which is transmitted from our TV remote, okay. And similarly for AC, okay, we will have a photodiode. So this diode will be present nearby to an LED, okay. So this LED will be there, so it is used to indicate, okay, whether your device is in switch on condition or off condition, okay. Near to this you will have a photodiode. So if you hide this photodiode, okay, with some object, you will not receive any signal from your remote, okay, because you know, right, photodiode is used to receive the signal, okay. Now this is what the situation. Now see here, so here I will use some photodiode and here I will use some other different photodiode, right? Now can I use my TV remote to AC remote? Will it works or not? It doesn't work, right? Okay. Now how they are doing this kind of differentiation? Now for example, see this, it is photodiode 1 and here it is, we consider photodiode 2. Now this is made up of silicon, okay. Now here we will consider this is made up of germanium, right? Now incident light will be greater than the band energy gap of the semiconductor, okay. This is the principle which is used in photodiode, okay. Now the band gap for silicon is almost around 1.1 electron volt, okay. And for germanium the band gap will be greater than 0.7 electron volt, Okay, so here the incident light should greater than this energy level, then only it will receive the light. Okay, and here the incident line should be greater than this, then only it will receive the light. So different type of manufacturer will use different types of semiconductor to differentiate their reception level. Okay, now if you don't press any signal in your remote, okay, whether your AC will function or not. For example, consider your TV remote. Okay, so you doesn't press any symbol on your TV remote. Will it will work or not? It will work. Okay, but if you press some operation, then only the signal will be, the light signal will be created from it, and it has to be received signal. Okay, so apart from other time, it has to be in switch off condition. That's why we need to connect this diode in reverse bias configuration. Okay, so when you doesn't press any signal, okay, the diode will be in switch off condition. When you press any signal, volume plus or volume minus or program plus or program minus, the light will comes out from the remote and it will be received by the diode. Okay, right? So other time, so the diode will be in switch off condition. That's why we need to connect this in reverse bias configuration. Okay, thank you.